everyone, welcome. So this session is, I don't know, could anyone guess from the title what we're going to do here? We're going to talk about a new piece of tooling called Web API Confluence. And it's a tool for kind of figuring out what things are available in which browsers and doing some interesting statistics based on that. So Mark's dialed in here. I'll get to the next slide. So this is Mark. He's the one who's actually done all the work here, and I'm just presenting. So we are part of the ecosystem info team. It's kind of a subsidiary of platform predictability. Most of the team in Waterloo. And so here comes the third and last slide, and then we're going to go to demos. So if anyone wants to, just while I'm talking, try this out and ask questions, that's fine. This can be more like a discussion and back and forth.
This will be our first stress test of the server, I guess.
Well, if it crashes, we can find a bug. I don't think it will. I think it'll be just fine. I'll just try clicking it. Okay, so what is this thing? So the basic idea here is that we have used a lot of the browsers are in browser stack going back to Chrome 30-something or 20-something, and old versions of Edge and Safari and Firefox. Gone back and all of these browser versions have checked out what you can find on the window object and beyond. So, oh, there's something called document, and there's something called document with a capital D, and it seems like one is the instance of the other. Kind of just walking around the window object, seeing all the things we can discover, and then putting that into a database and doing that for all the browsers. And so, kind of the raw data itself. Let's see if I can hide this thing. The data itself, the catalog is just a listing of all the interfaces and the things they have on them. So the default view here is Firefox, Chrome, Edge, and Safari. We can kind of discover what all the things are and do some searches. So if I click on an interface here, let's pick something that's not huge, maybe cache. Oh, there we go. Apparently there's something called cache, and it's in Firefox and Chrome. Okay. I had some searches I thought I would try just to see if there's something interesting. So let's try speech. What speech? There's an expand all. So there's this thing called Web Speech API, which was implemented in the WebKit days. And as we can tell, I mean, there's red on the screen. So that must be bad. So we have a prefixed implementation of the Web Speech API in Chrome. It's not in Safari apparently. Firefox has a unprefixed implementation of the speech synthesis part of that API, and apparently Edge also has part of that. Oh, you can see the cursor. So this is kind of an example of the raw data what you'll be looking at. So we think. So what are you going to do with this? We think that if, for example, you are working on a feature called something with cache, or maybe you just search for cache and see if there are any surprises there. So maybe you'll do that once and then file some bugs and go look at it. Or I think also maybe someone on our team or Rick or someone might once in a while just kind of look at everything and see if there's anything surprising. So this is the kind of the raw data itself. Let's see. I had some notes about things that might be fun. Yeah.
So want to show adding another browser?
Yeah, sure. Let's see. So let's actually let's remove some stuff and add some other version of Chrome instead. 38 is the oldest, I guess. So Windows 6.3, is that a thing? I guess.
Yes.
Okay, let's go with 6.3 and not expand so much, and not search for cache, I guess. Search for WebKit. I think that'll tell us something interesting. Expand everything. Okay, so in Chrome 38, well, they're in the wrong order now, but the Chrome 38 had a lot of stuff apparently. that was WebKit prefixed. That's no longer there.
You're just showing off now. Every one of these X's is something you did, right?
No, not all of them.
Okay, there's bad. We had not there in 38, but is there in 60.
Yeah, what was that? Scroll up a little bit.
WebKit relative
File, WebKit relative path. Yeah, I remember that.
Full screen arrow. Why are we adding WebKit prefixes?
Well, this was WebKit. We should maybe add another version in between that. We did add some WebKit things like 3 years ago or something,
okay.
before the Blink fork.
Oh, okay.
So that's it. That's adding 46, Windows 10, and then go back to, so they're in order. There we go. Is that more interesting? Oh, there's something strange. WebKit drops out and came and went.
Yeah.
Okay. I think that was Victor who did that, who got rid of that. So if you're interested in a feature, you might do some searching and see if there are any surprises. So that's kind of the raw data itself. We haven't really done a big picture here. What are we even doing here? I mean, so Dimitri talked about how on the web platform, to actually land things, you have to get them into all browsers. And so I think we should consider it a bug. So if we have all the 4 engines, and if any of the rows aren't all the same color, that's a bug somewhere. It could be a bug in one of those engines. It could be a bug in the spec that we need to sort out. But it's something that's at least worth triaging. Not everything is going to be worth prioritizing to actually fix right here now. But we should. The reason this is called Confluence is like the coming together of things, right? So we should want either all features to trend towards perfect interoperability or to be removed. I mean, there's some nuance there in but it's roughly speaking. So let's go to the Confluence metrics, because those are really about that side of the story. So as I said, we've done this data collection over a lot of releases. So we have the dimension of time here, which we don't have with any other data where we're working with or access to. Like web platform tests, we just don't know how those looked like 2 years ago. So we can do some interesting things with that data. I think I'll come back to API velocity last and just go over these 3 other metrics. So these are all a little bit nuanced. So for each of these 3 metrics, there's something called we have a grace period. So the numbers we see here are taking into account what happened a year before that point in time. So if there's a big jump in these numbers, it happened. Let's see. So if at one point in time, maybe it's easy with the removals though. To explain this.
The big picture concept is that we know that there's going to be, it's like the elastic band, right? We know there's going to be temporary stretch. One browser is always going to go first in some change. So the idea was to add a 1-year grace period to say, we don't really consider it a serious bug worth looking at until the delta between browsers has lasted for more than a year.
Yeah, that's right. And so failure to ship here is so what this measures is when 3 engines had something and the 4th does not. That's interesting. A lot of those
3 engines have had it for a year.
Right.
It's been in all 3 other browsers for 1 year, and not in that last one.
Yeah. So those are worth looking into. And I should say before we kind of, because these graphs have numbers, right, on the y-axis. But I think the absolute numbers here are, let's not put too much attention on the absolute numbers, which graph is on top of the other. I think the trends are more interesting. And the reason is we're just counting the APIs. So some APIs have a huge footprint, and some APIs maybe just a single entry point, but it's actually super complicated. So a lot of these big jumps, if you look into them, might be for something that doesn't seem as important at the size of the jump. So that's why I think the absolute numbers here perhaps aren't the thing to focus on. But anyway, I had some. Well, maybe, does anyone see anything interesting here that we should try to understand?
And also, you only look at name and existence of that if you don't care about the behavior of that
Exactly.
at all.
Yeah,
Exactly.
I don't follow what the other browsers implement particularly closely. I'm wondering about what happened in April of last year that caused the other browsers to, what did they unship a bunch of stuff or?
You mean things that are happening here?
Yeah.
Okay, well, I haven't looked at that before, so let's try to understand what's going on. So it went from 330.53 to 566, and these did as well. So probably what happened is that two of these browsers had an API, and then Chrome added it. Well, that's interesting. Was this like a big release for Chrome? 50? How can we find out? Let's just click stuff. Fortunately, we can't really
add it, like APIs from all other browsers, and then whatever the others miss, then the other will bump up it.
Yes, it's a bit these can be confusing because it's not the change in the graph isn't necessarily because something you did then. You as the browser. But let's see.
That's why there's a huge number of columns here saying like these are all the different browsers contribute.
I don't remember which is which here, but we can just go look for differences. Maybe it's last. Oh, this is a bigger list. Oh. Well, this wasn't one of the pre-prepared meals for the presentation, so you might not quickly be able to figure out what it is. Offline audio context. Oh, that was. Let's see. Well, there's just one thing that doesn't account for the whole difference, but apparently there's an incomplete event handler attribute on offline audio context, and that's changed. Yeah, so we would actually have to dig into that to understand why that's happening. Maybe
Is there any way to see diffs between like 2 points in time?
Mark, how would you go about understanding that big jump?
Understanding this particular example?
Yeah, the big difference on the green line here.
Yeah, I mean, unfortunately, we don't have an easy way to get the view that you really want, which is like show me the APIs that were added to the number between these two releases.
Yeah, I have a concern about the way it's presented because it's sort of, you could easily come away from this graph thinking that a bunch of stuff had been ripped out of the other browsers, and I really doubt that's the case.
No, this is probably, since this is a failure to ship metric, right? It probably means that there was something new in the web that made it to around this date, especially because we're talking about the Firefox line here that's really tall, right? Or is this Safari? No, green is Safari, right?
Green Safari, but
so
Firefox and Edge also had similarly shaped bumps at exactly the same
right,
time.
but that's probably because there was a particular release. Like we should go and see what version, what on this date,
50.
what was it was probably like, is this when Edge 15 came out or something, right? Or, there was some browser that released on this date that added a bunch of APIs that now meant there was an API in 3 different browser engines. There are APIs that was previously only in 2 is now in 3. And so Firefox is the last one to ship it. And so for a while.
The other thing, the thing that makes it hard to reason about is the grace period, right? Is that like actually what happened was a year before this time point, some third browser shipped something, and now one other browser was the odd man out.
It has to be 2 browsers that ship something, because like we have 3 browsers going up.
Well, there was 2 in the
Yeah,
past,
but they're all
who knows? That could
relative
have
to
been a long
being
time ago,
the
right?
odd man out.
Yeah, so
Maybe that
this-
there are a couple of releases here that are pretty close together. It looks like that happened at exactly the same time, but it's probably 2 or 3 releases from 2 or 3 different browsers that all happened within a month or 2 of each other.
So in one of the other graphs, there was something that looked super suspicious. I know this. Why is this correlated in the way it is? And it just seemed like that was accidental in that case. So anyway, I think the easiest way to use this data is to look at the last data point and just kind of figure out what are the things that in the latest releases of all browsers, all the other ones had. And I've already looked at some interesting examples there.
So just looking at that one example that you're asking about, this is a release where all the other browser vendors now show the supported CSS properties on the CSS style declaration, except for Safari. So this is a bit of an artifact, but a big chunk of this jump for Safari is that Edge, Chrome, and Firefox for a year now have shown the supported CSS properties as members of the CSS style declaration interface. So it's a little bit obscure, but it is technically hundreds of APIs that are available in 3 other browsers and not Safari.
What about the gems in Firefox and Edge?
I didn't click on those ones yet.
So actually looking into it, why the difference is, I mean, I don't know how to diff between 2 points, but we can look at the latest points in each of these graphs and see something
that's kind of more interesting.
That's what I was looking over. Let's see, failure to ship. So Chrome is interesting that it's so far down there. It's just a single thing, and that's
It's extract, invent,
yes,
something.
Exactly.
It's
So
not a flag.
I actually looked into this, and it turns out that Gecko's implementation always returns the empty string. So that's not super useful. Sorry?
We have an implementation. It's
But
working.
but it's not exposed.
Yeah, because the whole feature is not working.
Yeah.
So we
The
try to
inbound
do
text
that.
text is not working
Here,
at all.
click on it. You can see.
Sure. Yeah, there we go. Inbound metadata text. Inbound metadata track dispatch type. So this is a bit of a funny story. There was a bit of let's say a discussion about whether this should be added to the spec, and it was deliberately given a terrible name in the hope that no one would implement it. Unfortunately, that didn't work out. So we should probably think about this a bit. But the fact that Gecko does nothing is interesting, at least as far as I could understand the code. So anyway, that's we have. So it's not an accident actually that this number is very low for us. So Rick and I have been looking for these things and finding bugs.
I think this is new that it's this low. I think when I was looking at a prototype of this data like 6 months ago, I went through, I think, 20 different things that 3 browsers had and Chrome didn't have, and I filed bugs for all of them. And a bunch of the ones I found were actually already soon to ship in Chrome. So I'm really happy to see that we're down to 1.
Back and look at Chrome 55 here. There were 30.
Yeah.
Let's see if some pattern emerges. There are going to be things that we recognize from intents and stuff.
Mm-hmm.
Let's see. Takes a while to load when there are very many browsers. It includes the whole year of browsers. Okay, that's actually very boring. So the image and an option, that's because there was a change in the prototype of named constructors. So it just looks like there's an interesting change. Okay. I'll just take one example for some other browser for the failure to ship metric. Let's see. Yeah, I guess this one. So Firefox is the only only browser that doesn't have a. Let's see. Firefox is the only browser that doesn't have window.client information. Once window.client information, it's an alias for navigator. It returns the same object. So Edge, WebKit, and Blink all have this, and Gecko doesn't. And there's a spec bug file for it. It's super trivial, obviously, to add, but there's actually a bit of it'll probably get added, and probably in Gecko eventually, but there's a bit of a risk there that might not make sense for Gecko to do, or might, because it might be used for identifying WebKit, or at least not Gecko engines, instead of UA sniffing. I guess it shows up here somewhere.
So it was on window? It's gonna be on the second page now.
Yeah. Let's see. I should just not expand all. Let's see, window, client information. Yeah, there it is. And it's not in Firefox. Yep. Okay.
Window.event, Mike Taylor said, is one of their top web
Yeah.
compat issues right now. I think Mike Taylor's working on adding window.event to Firefox.
Offstream buffering is also hilarious. It always returns true in 3 engines.
Note that this doesn't we're not pointing fingers, right? So window.getMatch CSS rules, Firefox is the only one not to ship it. It's not standardized. We're actively trying to remove it from Chrome. We're going to break a bunch of the web to do it, but we think we can actually remove getMatch CSS rules from Chrome. So
Right, there's a caveat somewhere here about standards. I mean, this takes no account of whether something is in a spec, and this is kind of just raw data. Something to investigate.
On most wheels, another interesting one. All the browsers except for Firefox support it. Firefox can't support it. It's a non-standard. Most wheels a non-standard event. And this has just grown up in the stupid history of the legacy of the web. That people know that WebKit has mouse wheel and Firefox has, what is it, DOM mouse wheel or something like that.
Just
and like well, we all have wheel, right? Wheel is the standard replacement, but it's not used very much. It's the old prefixed ones are the ones that are used everywhere. And if Firefox tried to ship mouse wheel, you'd break, a whole bunch of sites would break because sites don't expect it to exist in Firefox.
How is that implemented?
How is
multiple events thing?
No. How is that? How do you guys detect
that an event is supported?
That an API is?
We're just walking the object graph, right? We're running on browser stack and just walking to see. We start with the window object and just walk around the entire object graph and find all the prototypes. So we're not guaranteed to find everything.
Right.
Okay. So anything that is returned from like a promise or something like that, you don't actually.
Right. We don't invoke any methods, and I mean, there's lots of stuff that has like no interface object. We won't find those interface objects, obviously. And it's like it depends on, so sometimes there is an instance to be found, like small d document. Well, that's an instance of big D document. So we'll have an instance of that, but we won't have an instance of events. So there are some things on event, like is trusted, that's only on the instances. It kind of shows up in the confusing way in the data.
And we can add some of those one-offs.
Right, we might want to kind of add instances of things where we know how to find them. Anyway, let's look at one of the other aggressive removals. So,
anyone have any questions on that failure to ship?
Quick question regarding numbers. So the API count, is it like, let's say there's an object and it has like 10 attributes. So you count it as 10 or 1? 10. All right.
Yeah, so some kind of weighting might make the graphs line up more with what you kind of intuitively think is kind of the importance of it. But then it would also be harder to interpret. So we don't know. Maybe we will do that. Maybe not.
It does kind of make some sense. I do expect bigger APIs that have more risk to have more methods on them, but it's just a rough rule of thumb.
Right. I guess the CSS.
So another question: how often does it get updated?
If there's a new release in browser stack, so
I mean, right now, if we want to update it and Mark does a run to actually collect the new data, it's not fully automated yet.
Yeah.
It's only for stable releases, right?
Yep.
And we know that I don't know, I assume we don't do that, but the other browsers don't have a Finch-Traut to enable an API on their stable releases, right?
We generally shouldn't be doing that much in Chrome either.
I know that we don't
does
do
have
that, but
application.
how about the other ones? Like,
I don't think so.
I mean, you could also have like emergency reverts on a point update of a stable branch that might confuse things a little bit.
There are some special cases in here, like we're only testing desktop browsers. There's some APIs like touch events show up as being Chrome only because it's only Chrome desktop that has some of the touch event APIs there all the time, where the other browsers either have it only when running with the touch screen, which browser stack isn't doing, or only on the mobile versions.
How much time do we have? So anyway, aggressive removal. This is for when one engine removes something and then 1 year later, so everyone had the thing. One engine removes it. Year later, situation is still the same. So what happened here? This looks surprising. This was the removal of the SVG pathseg interfaces from Blink, and so if we did this a lot, that would be worrying. So I guess I would say you have to sometimes remove things from the web platform, and you're not always going to get it right. So there should be at least some little bumps in this graph.
This one feels like a bug to me though. Like the SVG working group resolved to deprecate these APIs. They said these are bad, right? And Chrome took the risk by being the first ones to remove it. We took some heat for it, but it was manageable. It wasn't a huge, there were very many sites. Yeah. And basically all the people in the working group that resolved to remove it from the spec, nobody else removed it from their browsers. Yeah. So I think I actually pinged, I think there wasn't even a Gecko bug. I filed a Gecko bug for this. And I said, and I think somebody was like, yeah, you're right. We did want to remove that. We'll try to do that.
I think my point is there are two ways to make these flats go entirely flat. One is to be super conservative about ever removing anything. Then nothing is ever going to change here. And the other is being perfect at synchronizing removals within a year. And I think and anywhere in between that is going to be a little bit noise in the graph. So I think, well, if things show up here, it's not necessarily, yes, this SVG pathseg is a case where we should have gotten traction somewhere else. There is a Gecko bug for this, and the quote from the bug is, "Yes, we should do this, i.e., remove it." So that'll probably stick. Gecko will probably remove it, and then it'll be fine. Okay, let's look into the browser-specific APIs.
So just to clarify this, so the aggressive removal was like one browser has removed for more than a year.
Yeah.
And the other 3 browsers too.
Other 3, yeah, exactly. So Firefox also has a little bit of stuff they've gone first and removed, but this is all dominated by SVG pathsec. So let's see the final. So browser-specific APIs. So these are the APIs that exist in exactly one engine for 1 year. There's a grace period for this as well. And what I said about the absolute values of the graphs that don't really line up with what you would think. I was always expecting from a WebKit to show up high on these graphs, but that was before thinking more than 2 seconds about it, because they all share the same history, so they all have the same non-standard WebKit stuff. So Firefox actually shows up on top. And if you go click on these things, it actually is true that Firefox and Edge have a lot of odd little things that they that they haven't removed yet. I have some interesting ones. Let's see. Which one are we looking at? Oh, I guess I didn't write down anything. Let's.
What are we looking for? Just a good question. So we don't catch in any of these metrics. We don't catch anything that's basically implemented by 2 and not the other 2, right?
Exactly. So we're thinking maybe we should add a new metric, which is kind of what do you call them, split APIs, or the opposite of convergence, where we have exactly 2 engines. That's kind of the worst state to be in. Then you have it's further to go to full interop, and it's further to go to.
I'm sure we've got a bunch there that are like WebKit legacy that we should remove from Chrome so that they show up as proprietary APIs in Safari.
Right. Yeah. Okay. So, but right. There was something about WebRTC in this thing. Let's see.
There's the spreadsheet I sent you where I walked through all the Chrome specific ones.
Yeah. So for the browser specific ones, what I noticed is that not all of those are actually. Oh, I chose the wrong thing. Not all of those are actually kind of non-standard APIs. If someone is the first to implement a new thing and no one else follows in a year, that's also counted on this list. So I found there are a bunch of things in WebRTC that show up kind of contributing to Firefox's number there. But there the situation is actually that this back in the working group, they made decisions years ago and no one followed through. Except Firefox. And now that makes it look like that counts the same as if someone just shipped something without trying to standardize it at all. And also, I think it was a bunch of stuff on animation. They also were the first to have these DOM geometry interfaces. So you kind of really have to look at the data to understand what's going on there. Okay. Let's go back to API velocity, finally. So this is just kind of counting all the APIs and seeing where it's trending. And we should expect this to go a little bit upwards. So this is, I think the most interesting thing part of it is that Edge between 14 and 15 actually went and removed a lot of APIs. So they had some kind of concerted effort to clean up stuff in Edge 15, it seems like. So they had a lot of stuff that started with BHX.
Browser helper objects.
Still some of that left, but they removed a lot of it, made an actual effort. Let's see what else. Yeah, this was an interesting case. Default car set. That was a semi-useless thing that I removed from Blink maybe 2015, and then it was suddenly gone from Edge as well. So that's kind of a good story. There was no coordination there. Maybe it would have, if we did some coordination, things would probably work out better more often.
I mean, we should say that we started this, Microsoft did their API catalog years ago.
Yeah.
Right. And we started talking with them, and that's kind of where we got to a lot of these ideas. So they've been looking at data like this for a long time.
Yeah, Edge API catalog. Let's see. Well, I guess we're kind of out of time, but questions, so they have something similar. Yeah.
We should say that there was a GitHub link at the bottom. Play with it, and if you see anything, you question or you have ideas, just click the GitHub and file issues.
Is there any effort or anything to be able, like, to override just
polyfill the information and then just run it against the top million sites and then find out who's actually using any of these. I mean, because now we actually, if you have a good list of other browser stuff, we have decent stuff for Chrome, but we don't know anything about Firefox or Edge and seeing how they're doing it. But if we could just polyfill the data in and then just count who's actually doing what.
It means instrumentation to measure how often these code paths are hit.
To find out who's actually using any of these APIs. Because what's the use of then we could just say, hey, look, you guys, you're not actually using, nobody uses this. Get rid of it, please.
I think it wouldn't be too much work to combine this with use counter data when the use counters are in the IDL files.
So you're saying for APIs that Chrome doesn't have.
Exactly.
How do we measure the usage of those?
I mean, realistically, it has to be in instrumentation in those browsers because you have to kind of mimic them exactly.
And Mozilla and Edge all have their own ways of doing this. Safari doesn't have any kind of instrumentation like this, but Firefox and Edge do. We can do crawls, but in practice, the crawls aren't nearly as useful. There's a bunch of APIs that only get used in response to user interaction. So we've relied much more on our UMA data to tell us where certain things. And we've also got the UMA use counters hooked up to HTTP archive. So when HTTP archive does its crawl, we can do a quick BigQuery query to say of the HTTP archive crawl, which use counters are hit, which sites hit which use counters.
Yeah. I was just curious because I mean it's cool, but I mean unless I what's the point of knowing this data if I don't actually know if I can get rid of it? So
and we've got we know how to get rid of stuff well for Chrome. We've got a page if you search for Chromium Web Compat tools. There's a whole bunch of different tools like we're talking about here, and then we talk with the other browser vendors, and we've learned that sometimes one browser goes first and removing something, and their experience tends to translate well for the other ones. So there's lots of times where we try to remove something, and if it's successful, Firefox will try to. And we're always taking some risk, but usually when one's been successful, usually others can just follow without too much more data.
Is there and I noticed the versions specifically say Windows, and I wondered if there's occasionally there are differences between desktop and Android, and if you have a way to crawl Android data as well.
Sure. I mean, we know there are, as Rick said, touch events are Android only, and I think there are plenty of others.
Well, but I want to be able to select it and add it to the list.
Yeah, we want to do that too. Right now, we're limited just by performance. I think we have done some runs on Android, but it's a pretty big chunk of data.
That really is. I mean, yeah. Performance, I mean, it's just walking the window object and getting some data back.
We should be able to.
Hold
on, Mark. Say that again, Mark.
It's kind of surprising how bad it can be. Like, this has really shown the performance of, at least at sort of the platform, the JavaScript platform level, the performance of iPhone is like, we have almost no problem getting iPhones to run in the cloud and walk the object graph and not crash. And even with relatively new Android devices, you know, if it hangs, it hangs. Like, you don't have, when it's a real device running like on a rack in the cloud, you don't have very much insight into what happened other than that, you know, you ran out of memory, or because your script did too much stuff synchronously, the, you know, Chrome or the OS decide to kill it or whatever. So we've had a bit of problem with Android. We've had a couple successful Android runs, but it's not been altogether that robust.
Okay, on the speed thing, I don't need every Android version back to the beginning of time. That would be awesome. But for what I want to use this for, and the most recent version of Android would be good enough.
We should try to get some Android data in here for sure.
Okay, let's thank you, everyone.